Welcome everyone to exercise 43, which is an exercise which is about factorizing square roots. For those who don't practice enough, if you get this on the test, you would say no answer right. I did watch closely out. Mr. Opstraat said that if roots are not like, you cannot add them up. So here you have no answer. And before the newest theory, that would be correct, but remember, the newest theory is about factorizing square roots, which means that I should first try to see whether I can get that number that's inside of that root smaller, and that actually then sometimes helps you adding roots which are not like right now up. And it's important to know the squares for that. So again, in my PowerPoint and in the book you can find this list. I'm not going to provide the whole list here. I'm going to write down the list which I think is necessary here. I want to have the list of 4, 9, 16, 25, 36. And I think I can already stop here, but remember this list goes on and on and on. Those are numbers that you can calculate if you would have the root of them. Because you know the root of 4 is 2, and the root of 9 is 3, and the root of 16 is 4. And you can continue like this, right, for all those numbers. And those are going to help us factorizing those numbers here. Because if I have root 54, I'm going to try and rewrite it to a root times a root. And I'm going to try to do the same thing for root 24, a root times a root. And I'm going to do it in such a way that the first one, so this one for 54 and this one for 24, are from this list. Because if I do so, then after I've written it from that list, I can actually calculate them. And always try to take the biggest number from this list, because otherwise you're not factorizing completely. Here for 54 I should start with 49, checking for 49. All the numbers are bigger than 54, so those don't work. And I also see quite quickly that 49 and 36 and 25 don't work. Maybe you have to double check for 16, but I don't think that works either. So yeah, you have to go through the list in a motion and then you can get there. For example, root 9 here, I think does work, right? Because root 9 times root 6. Oh, think about that. That's not good, right? Need a cup of coffee. Root 9 times root 6, we could calculate to 3 root 6. And then you say, sir, how does that help? But yeah, don't go too quickly. Now try this for root 24 as well. Here I don't have to even evaluate those because they're bigger than 24. 16 doesn't work, 9 doesn't work, but 4 does work. Because root 4, and again, which number times 4 is 24? That's 6. Now gives me root 4 I can calculate, plus here, 2 root 6. And alas, not only have I factorized them, but I also have simplified them in such a form that I now have two like roots. 3 root 6 plus 2 root 6 is 5 root 6. See how this works? Let's try it again for B. Root 50 plus root 32. Surely those are not like roots, but I can factorize them. So write root 50 as root times root, and write root 32 as root times root. For 50, I check from this list. 49 is too big, doesn't work. 36 doesn't work. Hey, 25 though. That's the biggest one. That works. And again, and I don't have to check for 16, 9, and 4. The biggest one that works, you take root 25 times 2. Why? Because root 25 is 5. So you now find 5 root 2. Let's try this for root 32. I start from 25 because 36 and up is bigger. 25 doesn't work, but 16 works. Right, so you do 16 times 2, because 16 times 2 is 32, and 25 times 2 is 50. And this works because root 16 is 4, root 2. And alas, you find 2 like roots. So this is the same as 9, root 2. Watch out that certain numbers you can factorize in different ways, right? And I want you to find the correct way. For example, some people say, yeah, sir, root 32 is also root 4 times root 8. Yeah, but this is not factorizing completely. First of all, it won't work here because now root 2 and root 8 are not like. And also root 8 you can factorize again. So that's why it's so important to take the biggest number from this list and not just any number. Because then you get something that's not factorized completely. C. Root 8 plus 3 root 2. Well, this is actually easier. Because this thing, root 2 is so small you can't factorize it. But root 8, I can factorize it. Because that's just root 4 times root 2. So 2 root 2 plus 3 root 2 is 5 root 2. That's a weird one to now throw around to C because I think C is actually easier than A and B. Whatever book, whatever. Okay. Let's take a look at D. Now the list is gone here. If you have something like this on the test, you can of course write this list down on your sheet paper, on your grid paper. Let's try to do this without this time. Root 3 is so small I cannot factorize it. But root 12 is the same as 4 times 3. 4 times 3 is 12. Root 4 I can calculate. And root 27 is the same as root 9 times root 3. And again, this works because now I get root 3 plus root 4 calculated is 2 root 3 plus root 9 calculated is 3 root 3. 1 root 3 plus 2 root 3 plus 3 root 3 is 6 root 3. At E they try to make this more difficult by now putting a number in front here. Don't be too scared of that. That number there is just chilling in the front. Just leave it there. Root 20 I can factorize because again, if you find it difficult, 4, 9, 16, 25, 36, 49, yada yada. Hey, I can do it with 4. Root 4 times 5. So this is actually 3 times 2, and you could put it times here as well, root 5. Minus, and you add root 48, again do it like this, and 48 doesn't work with 49, doesn't work with 36, doesn't work with 25, and it does work with 16, strangely enough, because it's the same as 16 times 3. And 16 is 4, with 4 root 3. And here we have an example where at the end we cannot simplify into one root, because 3 times 2 is 6, 6 root 5, and 4 root 3. This is the answer, but still we prefer this over this because the numbers inside the roots are now smaller. That's what we want to have. Okay, and that they are not like at the end and I cannot add them up, that's totally okay. Let's take a look at the last one. Root 24 minus 8 root 6, okay, plus 2 root 54. Okay, book. The middle part is the least interesting because root 6 I cannot factorize. I cannot write it as a root times a root. Root 24 I can write as root 4 times root 6. This part I don't touch right now. And then root 54 I guess I could factorize as well. Let's see which number we can use. I think we already saw this one at A, right? So when you're going to make more of those exercises, you're going to recognize how to factorize as well. Here we can factorize by 9 times 6. And here we do find a nice string of root 6 again, because this is 2 root 6 minus 8 root 6 plus 2 times root 9. That's 3. So you find 2 times 3 root 6. 2 times 3 root 6 is 6 root 6. Can write it down as an intermediate step. I now do it as a small out of the equation calculation. 2 root 6 minus 8 root 6, say that's minus 6 root 6 plus 6 root 6. We have 0. Done. Don't write 0 root 6, because something times 0 is always 0. So just write down 0. That's a terrible 0. There you are, a 0. Okay? So believe it or not, this is the same as 0. Practice factorizing roots well, please. On the test you cannot use your calculator. The calculator can factorize quite well, but you have to do it on your own. Okay? Also, the graphic calculator in 4th grade and up cannot do this that easily, so it's good to have this skill well prepared for. Good luck!